I had JLC CNC make these for me, and typically of me, I sent off the wrong files for machining. So this, like the shape here, was modeled off some earlier iteration that I of course saved of the cylinder, and what it should look like is this. And so I've already machined this to the correct geometry, and you might notice I've added an O-ring. That was an afterthought where I realized it's better to have this as a phase seal versus a gasket. So O-ring groove. And so operations now is take these two and make them like this. I thought something was off when I saw the shape here, and you can see the difference. It's no biggie though, just more work, but I have time for work. Well, someone is actually a retard and managed to put this in the wrong way this time. It doesn't really matter. The geometry is almost the same. There's a slight bit more volume now in this pores versus this at the top here, because it was sitting, so the old cutouts here were, so it sat like this, and it was supposed to sit like this there. So two perfect ones and one kind of wonky. It's still perfectly usable, and now we won't have to worry about gaskets. And these are the same O-rings as used for the head, so only one size necessary. I'm not sure if I made an intro for this video in the previous shots a few days ago, so welcome back to my garage if I didn't. We're pretty much waiting for the cylinders to come back from Emot Racing for plating now. Should be here next week sometime. I've received pistons, 6 pistons, and I've got a bunch of extra rings in Colorado already. Exhaust flanges done. I've got this pipe which I built, and that should work well for the geometry in the cylinder and everything, but we might refine this and make some other pipes. The thing is, I want to test with this pipe first to see how it behaves, so that I know what I want to change, like RPM and all that stuff, you know. And this is simulated, heavily simulated in Emot 2T before designing the actual physical shape of it and making it. So it's not something I just pulled out of my ass. It's actually been simulated and should work really well. And my experience with simulating in Emot and building pipes is that it reflects reality and it works really well. What more? I've been looking at some belts I've got laying around here, just trying to figure out what width and stuff we need, because the belts currently on the bike are thinner than this variator wants. It would work, but it would we would lose lots of we would lose the lowest ratio because it'll expand more before it engages, and we'll lose the highest ratio because it's not wide enough. So we need I think 18mm wide belt in a length I don't know yet. Should take some. I think I have some measurements on my computer. Thank you, David Cook, for the Mitutoyo indicator. I need this, so thank you. Thanks a bunch. Perfect gift for a Mitutoyo fanboy. Also, thank you, Craig Caldwell, for the "You Bend It, I'll Mend It" sticker, the donations, and the ARC stickers going on the bike. Thank you. And thank you to everybody else who has been donating. Thank you through my old patrons. Thank you. Thank you to my new patrons. I'm gonna make some kind of a list and something to so you'll be recognized. I'm working on it. I'm afraid of leaving somebody out because well, I'm not the most organized in that department. Thank you, just thank you, and thank you for watching. Thank you for supporting me. Thank you for making this possible. So at the moment, there's really not much to do. We're kind of just waiting for the cylinders, and then we can assemble and start testing. There's an ignition unit on its way, Siltronic. Thank you, Siltronic. But if it doesn't arrive before we need it, we'll use the Ignitec for testing. But while waiting, I think we want to revisit something we were playing with a long while back. But before then, just a quick little... The current main engine is this, the one you've seen me working on, designing, building lately. With this cylinder. This isn't finished. Sorry I can't show you how it actually looks. But and this is a fairly conventional setup. It's the best I can do with the knowledge I've gathered throughout the years about how what makes a conventional two-stroke as powerful as possible. It didn't start here though. It started with what you see the remnants of here. It's a Peugeot SBX crankcase, and I modified it. Well, the pieces are not here anymore, but I widened the case with some aluminium pieces and a JB weld, and managed to get that to work with a Peugeot SBX cylinder. And so this was kind of like the first iteration, and then I went water cooled, and so this is many years ago, and this led into the current engine in the Landspeed bike, which also was built many years ago, with my custom case and the IAM M50 cylinder ported. That was the best starting point for porting back then, and still a really good starting point for porting. I always wanted to build something completely custom and incorporate a bunch of my clever ideas. And so that led to this engine, the first PIP engine. PIP stands for Primus Inter Pares, which means first among equals. And this has been through a lot. It was meant to be a twin intake case with a reeded intake for starting and bringing it up into the power band, and then a resonant intake here with no valves at all, just a resonance, like the length was tuned for the correct frequency. Started like that, has been through a reed setup, rotary valve setup, and the cylinder started off as what you see here. So this was cast by me. This was my, I think, first or second successful casting of a cylinder. I think I needed 7 attempts before it was successful. There's still lots of porosity here, but this was cast, lost PLA cast at home here. Also plated by me, also successful after I semi-successful. The first plating was really successful. The bond was great and stuff, but I used the wrong kind of boron nitride. Switched to silicon carbide, and that's the plating that's in here now. The special thing about this was how it has a 100% of bore width exhaust port, and we were running these super special pistons with a captive ring with like a pin that held it in, and so this ran, and it's still worth visiting, but the problems were like the rings were breaking because of little material in the, I don't think I have a ring here, but because of design issues. But this cylinder has a bunch of other things that was also experimental, like these ports. Like the wall angles are retained from entrance to exit here, but might cause issues. The jury is still out, but the main problem was all the experimental features at one time, simultaneously, and it just made it impossible to see what was wrong or what wasn't wrong. So we started modifying the cylinder. So this cylinder first got exhaust bridge welded in by Emot Racing, and we didn't have much luck running it, and then I started trying to make it more conventional. So you can see how there's inserts here, making the ports look more like they do here, in the more conventional setup. And also I started making so now there's a 3-port design with a sleeve, and we made the exhaust port more conventional looking. Still not very conventional, but more so. And actually started seeing good results on the dyno. Then well, we had kind of a jack shaft setup and realized how the primary reduction of the jack shaft setup really impacted power delivery, and so that was a thing going on. But so this kind of led into a fresh start, and the current engine, where there's nothing experimental going on here. It's just the best I can do with what I know to work, or why I know engines are powerful. And the plan is to introduce experimental stuff, but baby steps now, not like we did here or started with here, where everything was experimental. There's been lots of other stuff going on here, testing of various like nitro injection things and stuff like that in other engines, like mule engines, but that's never been the main. There's been some confusion where people have like talked about how the engine makes so little power after all the work I've done, but the engine in question is actually just a test engine with a stock cylinder just for testing nitro or something like that. But there's been like the main bloodline is what's come before this engine, everything I've showed you now. But there's a separate parallel bloodline, and that's the brute force concept engine. And I think maybe it's time to revisit this now as something to do while we're waiting for parts. Last time we played with this, we had a failure, a reed valve failure, reed cage failure, and I've 3D printed new ones a long time ago. We never tried them, and regardless of the power this makes, it's a really interesting and funny engine because of how it's built with the blower and everything. Brute force concept engine. So for the uninitiated, this is a supercharged, externally scavenged. By that I mean, even though you see the blower blowing into the crankcase here, the crankcase is not connected through normal transfers. The crankcase is connected to the cylinder via these bends, and then there's a reed valve on each side here going into those transfers, and the transfer ports are almost as high as the exhaust port. That's why there's reed valves here, because after combustion, when the piston is on its way down, the exhaust port opens, and then there's like a millimeter or two, if I remember correctly, and then the transfer ports open. And the reason for that is to have variable transfer timing, where there's plenty of room to build pressure before this closes, the rotary exhaust valve. So it's designed in a way that at around bottom dead center this starts to close. And it closes, but the transfers are still open, and it can build pressure. That's the theory, and it seems to work. It definitely runs. So last time we destroyed the reed valves. We've destroyed many reed valves, and specifically the cages break. I think that's what's happening. There's too much pressure for a normal reed valve because they're not meant for this application, and the pedals slam into the bridges in the cages and they break. So this design has 2 bridges per side, and they're also supported all the way through here, so they shouldn't be able to break, and that should keep the pedals from breaking too. Hopefully, we'll see. So last time everything was running fine until we broke the reed cages, and it spins freely. There's some carbon fiber dust and stuff in here, but I won't disassemble. I'm just gonna clean stuff here and reassemble, and then we'll hook up the ignition system, and we can actually just start this and see how it behaves again, for fun and giggles while we're waiting for our cylinders. This speedway carb has worked very well for this application. This is pretty much a controlled leak, and but it delivers delivers lots of fuel. So this runs on methanol and nitromethane. I can't remember if I designed it to be like this or if it's just luck, but by design now there's no tensioners needed. I know I ran tensioners on both belts. So now we gotta time the valve. I want the valve to close, start closing at around bottom dead center. So now let's spin this to, so there's bottom dead center. And then we'll set the valve to close there. So now the piston is on its way down, the valve starts closing at bottom dead center. It travels to top and the valve opens and then the piston uncovers the port. Perfect. There's a gasket here with gasket goo on it. Hardened gasket goo, and the same here. And I think that'll work perfectly as like a rubberized sealing surface. So let's get the new reed valves in here. And in here we can actually find the remnants of the previous reed valve. Last time I assembled this, I couldn't find my adapter plate for the actual intake for this. Now I've found it, so I'm gonna replace this with this. I used this and then a piece of hose. That was unnecessarily long when this is much neater. Okay, so this was a waste of time. We'll have to use this. So this was an adapter for something else, probably the PIP engine in some stage. So forget about everything I did here. I'll be back when this is back on and I've found a piece of rubber we can use to mount the carb. So that's 1, 2, 3.2 millimeters. There, it's butted up against the... And now I want this to be centered. I want the trailing edge to be centered over the sensor. That's the best we can do with the splines. 2 millimeters. It looks like it's sitting, the trailing edge leaves at roughly 2 millimeters. So that would be about 24 degrees, which is fine. And as we've had issues with runaway engines, but not really with this one, but we're going to use a surface gap plug, and that might be problematic at higher pressures, but we'll see. Might be the Ignitec won't be able to fire it. Did I mention this has 20:1 in compression ratio at the moment? 20:1 compression ratio did this to an earlier head. The one in there now has a fillet here for more material in this area. I've been testing out various ways to get drive out of this. The ignition trigger is like, this was never meant like just a prototype, just for testing purposes. So this was built so that I could use a chain to the dyno. The dyno, which is that dyno failed, the brake disc dyno. I had a belt drive, like I think it was this, to the retarder dyno and stuff. But at the moment, well, a variator won't fit because of the trigger. That's the problem. For now, I want to put this in a frame. I really would want to put it in this speedway frame, which has a clutch and a pulley on it already. So I might fabricate a small pulley. It won't be variable, but it will have one gear for testing. For now, we're just gonna put this on there as a flywheel, and then start this up in maybe mount it in the vise, something like that. Nitromethane injection test bench, or other stuff test bench. At the moment, that's what it's been serving as. We could probably try to run this on my pure nitromethane oil mix here. I think maybe mixing some methanol in there is a good idea. Color is different. I think it's been eating the inside of the fuel lines, or maybe there's some rust in there, something like that. It's been sitting with nitro now for I don't know, half a year, something like that. So might be some issues in there. I'll have to filter this to get the black oil residue out of it. This has been sitting forever now, pure nitromethane with a Klotz Techni plate and no separation. So that's good to know. So the Techni plate oil, if we're running methanol, ethanol and nitro, then that's our oil. It's methanol and 30% nitromethane and 10% oil. Forgot to mention I put a tensioner on here, and the reason is without that tensioner the belt would hit the exhaust stub thing, flange thing. We're gonna hook up our coolant system, which is just a big pump in a reservoir. And the water sitting there is it's vintage water. It's been there for years and years and years. Ever since the first, it's the same water as we used for the first tests of this engine. It's holy, lucky holy water. Maybe that's the problem. Maybe it's the opposite. It's unholy water. It's pumping water and there's no leaks, it seems. Good. Could be internal leaks though. I think we're ready to go. It's just a matter of hooking up programming the Ignitec unit to 25-ish degrees. That should be in the ballpark. And let's see what happens. The reason for this stiff rod versus a cable, you might remember, is the blower will suck the slide like this and just keep it in any position. Like I have to be able to push it shut, otherwise it will stick halfway open. We're ready for startup. Ignition timing is set to 20 degrees before top dead center. Should be. Probably not accurate because of how we've just estimated the trigger point from visually inspecting the load position in relation to the trigger. But it should work. Exhaust extraction is not hooked up. So this will be, thanks for watching, see you next time. Because it will be pretty much unlivable in here for a good while after this because of the nitro fumes. I just made some coffee, so give me 5 minutes here. Otherwise I'll just have to throw this away. I'll spin it over a little bit without the ignition turned on. Just fuel. To get some fuel in there and just soften everything up. This might not be fast enough. Unfortunately I destroyed the other fast enough ones. And my starter is counterclockwise. Now with ignition and see if... I don't think it's fast enough, but we'll see. Wait, I thought this was bent. That's funny, isn't it? Supercharged, externally scavenged, rotary exhaust valve, 2-stroke. And that was with the lowest pressure possible. Let's speed it up one more time, but this time give it... you know what? No, let's not do that because we have no pressure gauge or anything here. But it still runs. It would be so cool to put this into a frame of some kind and do the testing in a frame. I think we need to do that when we have time. See you next time. My eyes are burning.